shorelines are likely are invading the land and with the effects on um, existing infrastructure and the ecological habitats. And of course, people have been trying to monitor those coastal lines. So mostly using some aerial photographs and or radar data sets, which seem to be a bit expensive. And then the Africa thought, how could you tackle the issue using some freely available medium resolution imageries? So this notebook was developed using Landsat imageries. Those are 30-meter resolution, and we hope it would bring some solutions to coastal erosion monitoring at cheap uh, price. So now this notebook mostly is based on NDVI no Landsat time series, and we are using mostly the modified normalized difference water index to monitor the water extent, but also we are using tide height to filter the imagery, make sure that you don't confuse the height of water and the land, but also that the same images were taken at approximately the same sea tide height. And of course, you could see between several periods how the composite image look like, and then after try to extract the shorelines across all times. So now we have an ongoing project. I'm working on it with CSC team, especially Lamin and Fatou, and we'll be working we are working on the Sare Potido area for a kind of test to see how efficient will be our results will be. So of course, we should load all functions here that will pass to both import, display, even mask counts and so on. And what we do, we be focusing on this area of Saleh Potido. It's somewhere in Senegal, and we hope to see how the shorelines have been shifting, have been invading the land. And what you could see, you know that we have like three aspects, three Landsat data sets. First of all, we have our Landsat 8 that dates from 2013-14 to nowadays. We also have our Landsat 7 that dates from I think 2002 until nowadays, and we have Landsat 5 that lasts from 1980s to 2010s. So we'll be using those Landsats, and the idea is to see how we could monitor the coastal erosion using all those Landsat data sets. So I won't be too technical, but if I go, I can go immediately to the output so that you could start here. So we focused on the tide height, of course, to make sure that the same images were taken at the same sea tide height. So you see for Landsat 8, the tide height were varying from -4 to approximately 0.8. And we hope to keep the tide height that between the mean and the maximum. The same way for Landsat 7, and as you see, the Landsat 5 was behaving strangely because some images were missing. Either they didn't meet the required minimum cloud cover, and then we left them out. And after filtering, we could filter them by the tide height, as you can see. And if we combine our observations, now we could see from Landsat 8, we have the imageries from 2013 until 2021. So those are kind of composite imageries for that times, those time steps. And if we go for Landsat 7, we have images from 2000 until nowadays, 2021. So, but if we go for Landsat 5, you could see some imageries are missing. And this, as I said, this is due to some lack of imageries due to high cloud cover, so that they could be useful for our use case. And after what we did, we tried to extract the shorelines. So here from Landsat 8, we were able to extract the shorelines from 2015, 2021. And as you see, there have been a kind of shifting in the shoreline between the two imageries, the two time intervals. So the same thing, the same way we started from Landsat 7, that's from 2000 to 2021, always trying to see what is the distance of shoreline shift. And for 2000, for Landsat 5, you see, you can have some idea how it looked in 1980s in the right line, and until 2011. So now the issue here is, through this DE Africa existing notebook, we were able to extract those coastlines, but the main issue is how our results reliable. Are they really useful? How are they closer to the reality? So this is the step at which you are. And if I shift to my PPT, the step at which we are, it's trying to validate. So the sets are in French, but I think they're still useful. So now the thing is this: we have been extracting those shorelines from this Salé Potido in Senegal, and we need the validation datasets so that you could compare them with what you've done and say what is the shift distance, how far our results closer to the reality. So now we have the shoreline reference shorelines from 2002, got from this author Adamafe, 2007 the same author, 2012 from the same author, and also 2021, and that we got from CSE. And of course, ourselves, we were able to generate those coastlines. And now the idea was to compare to see how far we are closer to the reality. And If you see, this map tries to show us some. This is Potido in the square, and we have those shorelines from 2002 and 2021. Here are the coastline that we have generated, and we are asking ourselves, how shall we validate this data set? So we should create some transects and try to generate some perpendicular point, one from the generated coastline, the other from the validation data set. And the idea was to run some statistics, especially the root mean square error, to compare what is the error or what is the shift compared to the generated the validation data sets. And this is the way we did extracting our validation, our point, our validation point, and we used like 23 points, and we tried to calculate all the latest statistics. And if we go to 2021, we could see that the absolute error for 2021, the highest was 10.11, and you keep in mind that Landsat imagery, the pixel size is 30 meter resolution. Of course, for 2012, we had the highest root mean square error was 30, and the lowest was approximately 0.19. So you remember, most of the others were around 15, almost a half a pixel of velocity satellite imagery. If you go for 2007, you could see now we are running, the highest was less than a pixel, or the imagery was 21.13 meter, while the lowest was around 0.784. And for 2002, if we go, we could see the highest was almost 2/3 of a pixel, which was 19.54, while the lowest was around 1.40. So, and overall, if we compare all absolute errors or root mean square errors for all years, we could read that somewhere in 2021 we had almost at the point 10, we had almost around a pixel of the used imagery around 30 meter. For others, we were less than 2/3 a pixel, and most of them were less than half pixel. And if we try to compare using the mean, root mean square error, so we could try to see for 2002 the average LMSE was 7.65. That's approximately 1/4 pixel of the used imagery, and that was a good result, with precision. For 2007, we had almost 10.10 something. And if we try to see, it was less than 2/4 or even 1/3 of the pixel. It was always tolerable. The same way for 2013, approximately less than half a pixel, which was also good. And for 2021, less than 1/4 pixel, that was a very good precision. So, and the idea is to say, as a conclusion, it means that using the Landsat imagery to monitor the coastline erosion could be efficient, cost effective, because it could at least help us to keep the error at almost less than half a pixel or those the imagery. So the challenge you still have, it's how they used validation data sets reliable. That's one issue, because they got them from several sources. And also our team is still working on the improvement or the script to improve the precision. And but still we could read that this is a cost-effective approach compared to the others that have been used, and the precision is still useful. Yeah. And from this, I do thank everyone, and Johnny puts the most welcome.
Thank you very much, Joseph, for this great presentation. Everyone actually is clapping. If anyone has a comment for Joseph, first of all, we congratulations for this wonderful job and the partnership you have with CSC. Maybe if there's someone from CSC who can add some more information about this wonderful work.
I could see Lee Song, I could see Fatu, or say Alpha. That's the most welcome.
So as they share this information, is there anyone with any question for Joseph?
Yeah, I have one question.
Yes, Bako.
Yeah, thank you, Ken. I want to congratulate Joseph for this good presentation and for sharing this approach with us. My question is about the quality or the accuracy of the result. We have the same satellite, same resolution, same the techniques to have those images. Why this difference between years in the result? If we want to conduct the same, do we have to use the same Landsat image, or your advice is about another one? Because we have the same coastal area, we want to conduct the same studies. Do you advise us to use the same satellite, or we have to use if we want to increase the accuracy? Thank you.
Okay, thank you, Bako. First of all, we focused on the Landsat imagery because it starts from 1980s to nowadays. So it has a high in each time series, because we are relying on Sentinel dataset that starts more or less 2017 to nowadays. The time step is still low. So first of all, we prefer to start by Landsat, but it doesn't exclude the use of Sentinel, although the time step or the time series will be limited. That's the first thing. The second thing, when we talk about the difference in results, it is still a challenge, because the validation data sets we got might change, because the way the provider has illustrated those data sets, we were not very sure about the efficiency of the methodology. That's one, because we are comparing what have been generating with what might have been generated from high resolution imageries with the higher precision. And this could help us to compare. But if the way validation sets are not standardized, if I can say, we'll be still facing the same issue. But for as far as the sandbox, our notebook is concerned, the same script, the same image, the same place should always give the same results, unless we change the resolution of the imagery. Of course, if the resolution is good, we'll be increasing the precision, and if the resolution is coarse, the precision will be reduced. Did I answer your question, Baku?
Yes, thank you, Joseph.
Welcome.
Also, Joseph, I think if there's something, because this was a very difficult question, it is that what phenology changes. So, for example, this coast was different. The coast of Dakar is different, and also, is there any human activities ongoing? So some coasts like the coast of Kenya, it could be similar, but you'll discover the government has been doing some dredging or reclaiming some land for some activity. So these are some factors to think about when you do your work. For example, for another coast, the activities being done, and CSE was very gracious to share some of the photos, including area imagery, and also possibly Landsat was used because of the time. So they wanted something from 2013 to 2020. This will be Landsat 8. So hypothetically, we could change to Sentinel-2. So it means we can work from 2017 to date. So these are the opportunities which are there. And also we can also think internally of adding radar information to make these possible. So this is open to discussion for everyone. Together we can make this notebook any direction possible, so long as we give the results intended. So as we think of a question to ask, I wanted just to show the same example for Joseph. So this was the coast of Dar es Salaam. So there is a peninsula called Masaki. It's just the coastal of Dar es Salaam is very unique. We have some peninsula areas. So this particular one of just around the sea cliff, they've been doing some, there's been some dredging activities, or there's been changes. Then the problem of cloud cover. So with DA Africa, it is able to get good coverage of at least 50% or 60%. So going back to the same question of whether we could use some other imagery. Then going down, we see some of the results similar to what was showed by Yusuf. So having a time frame from 2013 to 2020 will be very useful for communication with policymakers, and also the dates that were captured. And the output from the DA Africa as well, which was shown by Joseph, is that you'll get a file called an output waterlines, which is this one. And each waterline has a different date and different color, which can be very useful as we explore the areas that we are working on. And even overlaying with an Esri imagery, you're able to see very good results. And you can still explore the same shoreline here as a JSON file, which you can also take to your GIS software, QGIS, or et cetera, et cetera. So these are the possibilities which are there that we can make use of these tools to make sure we help the right decisions. So I was thinking the same coastal erosion can be used for Tunis, which could show different results. So this is an opportunity for everyone to try it